Factor is both a verb and a noun. To factor a polynomial means to break it down into smaller pieces called factors. If we multiply the factors together, we end up with the original polynomial. So factoring and multiplying are opposite actions. Depending on what polynomial I give you, you're going to want to try one of 4 things when you factor. These are the 4 methods we will use in this class. The first method is to divide out the greatest common factor, the greatest common term, the greatest number and variables, x's, that they have in common. The second way is to use the difference of squares identity. That only works if you have 2 terms specifically. The third way is the bottoms up method, which only works if you have 3 terms. And the last way is to group, which only works if you have 4 terms. This video, we're just going to focus on the greatest common factor. When you factor a polynomial, you can use combinations of these different methods here as well, which you'll see in future videos. The most common combination is to mix greatest common factor with any of these other 3 options. So, what is greatest common factor? When you're factoring a polynomial, the very first thing you should ask yourself is, do all terms have anything in common? Can I divide a number or variables from all terms? So in this first example, I can divide a 3 from both 3x cubed and from 6, negative 6x squared. They also have some x's in common. You want to pull out the biggest possible number of x's. X cubed is the same thing as saying I have 3 x's. X squared is the same thing as saying I have 2 x's. So at most, I can pull 2 x's from both pieces. I can pull these 2 out and these 2 out. That means we are going to divide or pull out an x squared term. So when you factor it, you pull in front whatever they had in common. So they both had a 3 in common and they both had an x squared in common. When we divide that out, 3 divided by 3 is 1. Subtract your exponents. So 3 minus 2 means I'm just left with an x. And in the second term, negative 6 over 3. Negative 6 divided by 3 is negative 2. And 2 minus 2, if I subtract my exponents, is 0. I don't have any x's left. They cancel each other out. So this is my final answer. What I divided out and what was left over when I divided or pulled out this common term. This is the common term, or the greatest common factor. So my 2 factors here are 3x squared. We don't usually put parentheses like that since there's not a plus or minus, but it may help you to do it that way. And the other factor is x minus 2. If I multiply them back together or distribute the 3x squared to both of these pieces here, I'll end up with the original problem. Okay, let's do some more examples. Okay, the first thing you want to ask yourself when you're factoring is there a number or x's that I can divide in front that they all have in common? 16 and 4, I could divide a 2 out, but you want to pull out the biggest possible number, so I'm going to divide out a 4. Don't forget to write this number. This piece that we divided out has to be written in front. If you forget it and just write the x minus 2, it's wrong. You need to be able to distribute this back to get the original equation. So do not forget this term. It's really important and a lot of people forget it. Okay, so we divided out a 4, but they also have an x in common, so I can pull an x out from each piece here. 16 divided by 4 is 4. X squared, if I pull one x out of these 2 x's here, or if I subtract my exponents, I'm left with 1. In the second piece, 4 divided by 4 and x divided by x, a lot of times people say, oh, they cancel each other out, so I don't have a second piece. But if everything cancels out, use 1 as a placeholder. If you had 4 cupcakes and you ate all 4 of them, you didn't eat 0, you had the 1 whole entire box. So that's why we use a 1. And if I distributed my 4x back to both of these pieces, I'd get both the original parts back. You may want to pause the video and try and do these last 3 examples yourself. I'll do them really quickly. Divide out what they have in common. So I pulled out a 4x. When I divided that out, I'm left with a 2x plus 3. For D, don't forget that 1 as your placeholder. And for the last one, all of these examples have only shown you binomials, things that have 2 terms. This one has 3. You can use this method to factor any kind of polynomial, no matter how many terms you have, but you have to make sure that what you divide out is in common with everything, all of them. So yeah, I can take a 2 out of here, but I have to be able to pull it out of all 3 pieces. So in this case, there's no number that I can divide out of all 3 of them, but I can pull some x's out or divide some x's out. I can divide the x squared That's as far as I can take it. You can't actually factor this any further.